I was asked to give a presentation that really looks at the intersection of issues around agriculture, food security, and the state of the global environment, and to see if there are solutions that can bridge those very different kinds of worlds. But as we think about the future of these very complex issues of food and land use and the environment, it may be best to begin the conversation with a little bit of a retrospective look at where we got through our recent history. How did we get where we are today? And why this time is so critically important in the history of our species. The reason this moment in history, I think, is so important is that it represents a kind of a discontinuity in our civilization. If you think about the length of human history, whether you think of 10,000 years since agriculture was invented, or maybe a couple 100,000 years of modern humans, or millions of years of hominid evolution, whatever time frame you look at, there was one thing that was always true. The Earth was essentially infinite, and we were very, very small. And we always had room for more resources, more places to go, more places to exploit, more places to spread our growing population and our economy. But that fundamentally changed in the recent history, and it suddenly looked like the Earth shrank all of a sudden, and that we got very, very big. Now, of course, that happened for two very fundamental reasons. One is that our population, really kind of exploded during the 20th century. About the late 18th century, we saw our first billion people. At the end of World War II, we were over 2 billion people. Today, we're at roughly 7.2 billion, and there are about 2 billion more people on their way. And there's very little we can do about some of that population growth. A lot of that's due to the fact that people are living longer, and there's some demographic inertia because there are so many people under reproductive age on the planet today. So while fertility rates and families are getting smaller, there is still a lot of population growth yet to come before we stabilize the Earth's population, probably later in this century. So that's one big fact, is we're adding billions and billions of people very, very quickly. The other, of course, is that we've exploded our use of technology and resources around the world. This picture you see behind me is a picture of what Earth looks like at night from outer space. There are no boundaries on this map. There are no lines. There are no drawings at all. But yet you can see quite distinctly over here, this is India and Japan, there's South Korea, there's not North Korea. I always find that kind of interesting. That's Kim's house, I think, right there. And, sorry. I probably shouldn't make fun of him since he's aiming nuclear weapons at us in the United States right now. But we see, the differences of technology and, our incomes and, infrastructure, even from outer space. It's obvious that we've become a technological species, and our ability to harness resources has dramatically escalated in the last few decades, and that's incredible. And if you really think about it, these changes in population and technology and resource consumption have truly accelerated during the last few decades. For example, just in the last 50 years, during the lifetime of most of us in this room, between, let's say, 1960 and 2010, just for round numbers, the Earth's population more than doubled during that time. The economy grew sevenfold during that same time, adjusted for inflation, even including the end of the last recession. So we have twice as many people doing 7 times more commerce on the planet. That required about 3 times more water, 3 times more food, and about 4 times more energy, at least in the form we currently use, which is primarily fossil fuels. And what's so extraordinary about this is not only did the last 50 years change more than any other period in history, it changed more than the sum of all human history put together. And so no matter how you look at this recent period of history, the time we've been alive on this planet, we've seen an inflection point in all of human history. Everything changed, even the way we changed in the time we have been alive. And so that presents an enormous challenge to everything, whether it's food, the environment, security, the economy, everything. These are enormous challenges. But one thing is absolutely true. And environmentalists like me are never the ones to tell you this, but I'm going to anyway, is that in fact, things have gotten a lot better, mostly. We live longer, healthier lives under more just and democratic regimes than any civilization before us. We are actually more secure, we are safer, more people are literate and healthy, and this is good stuff. But, and this is where the environmental folks get into the question, we always have to bring down the dark side of it. This is why we don't get invited to parties very often, as you probably figured out, or never more than once. So what you find is that, yes, we have built up this incredible, prosperous, thriving civilization, but to do that, we've essentially run out of planet to work with. It doesn't mean we're running out of everything tomorrow, I'm not saying that. But we went from an era where resources were essentially infinite, always cheap, very secure, very reliable, and very inexpensive, to an era where resources are now looking more finite. There are more players competing for them. They're not always so secure, they're not always so inexpensive, and they're often quite volatile. And so that's the new era that we are entering right now. And let me show you a few examples of this. One of the most fundamental things we seem to be kind of running out of, if you will, is good available land for agriculture. This picture behind me is a picture from the eastern Amazon forest in Brazil, in the state of Pará, near the city of Belém, which is where the Tocantins and the Amazon meet in Brazil, in the kind of eastern part of Brazil. This was a rainforest. It was burned down to create a pasture. This is just a kind of a peasant farmer claiming some land. There'll be about 1 head of cattle per hectare at most in this region, extremely low densities of cattle grazing, because it isn't about growing food, it's about claiming land. But this is an extraordinary change in land use. If you were to step back and look at another part of the Amazon, this is now towards the south part of the Amazon basin in Bolivia, what we see here is a picture of basically a virgin rainforest here in 1975. That whole green carpet you see is intact natural forest, hasn't really been touched. But if you look very carefully, right there, you see a dirt road through the forest, and there's one rancher out there all by himself, out there in the 1970s, surrounded by jungle. I love to imagine this guy out there wearing, bell-bottom blue jeans and listening to ABBA or something out there in the 70s. Who knows, It was the 70s, anything was possible. But if we go back to exactly the same place with the same camera and look a little bit later, we see an extraordinary change. What the frontiers of the last remaining rainforest were cleared into this, basically monocultural system of agriculture. This actually looks a lot like the United States, frankly. When I walk around these landscapes, I think I'm in Iowa, because these are almost all soybean fields. And these soybeans were being shipped to Europe for a while after the mad cow disease scares in Britain and so on. But now, most of those soybeans are heading to China as pig feed to produce more pork for the exploding size of the Chinese middle class, who are desiring more meat consumption. So we went from feeding people in China more pork from a virgin rainforest in only a decade or two. That's just extraordinary. And if we step back even further, and this is the kind of work my research group does all the time, as we track the land on Earth everywhere, every hectare of land, from satellites and ground-based data. And what we're finding is that we've used up most of the good available agricultural land on the entire planet. It doesn't mean we're using it wisely, but we've used up a lot of that. Like the green areas up here are the areas of the world that are devoted to growing crops, our cropland areas. They're growing, wheat and rice and maize and soybeans and cassava and whatever else you like. That's 16 million square kilometers of land in crops. That's about the size of South America, to put it in perspective. The brown areas are the areas of the world that we devote mainly as rangelands and pastures. A lot of them are kind of in arid places, but that whole area where livestock graze and these kinds of things, that's about 34 million square kilometers, or about the size of Africa. So we have 2 continents worth of land growing our food right now. And if you ask yourself, well, how will we grow more food in the future? If we're going to do it through expanding the area of farms, where would you go? Siberia? Well, not likely. The Sahara Desert? Not likely. Greenland? No, not going to do that. You're going to look here in the Amazon, or in the Congo, or in the Indonesian archipelago. Those are the last frontiers for agriculture. The problem is there's a rainforest there, and we might like to keep that. So that's one of the pressure points on the world system. But right now, we have already cleared 40% of the Earth's land, excluding Antarctica and Greenland, because we're not going to farm those. But 40% of the ice-free land has already been cleared and paved and grazed, and almost all of that was for one thing: agriculture. 39 of that 40% is for food, 1% of that is for all of the world's cities, pavement, and road systems. So that's an extraordinary amount of land, and almost all of it is for food. So we have a land problem we're going to be facing in this century. We also have a challenge to fresh water, of course, too. Believe it or not, this picture is taken out of an airplane window flying into Phoenix, Arizona, in the southwestern United States, in the desert. And what are we growing here? Well, I don't even know. I've been asking people who are, who I think would be able to tell me. The best guess we have is something called iceberg lettuce, that kind of tasteless, weird white lettuce you get in the United States. You guys don't eat that over here, I know, but we get a lot of that crap in our salads. And it's been grown where? In Arizona? That's crazy. This is absolutely nuts. But yeah, a lot of people are comparing notes on their salad recipes now. But where did this water come from? It came from here, the Colorado River, which was once one of North America's great rivers. This is a picture of what the Colorado looked like near the Grand Canyon in the United States in the 1950s. This is just a typical day, not a flood, not a drought, an average day in the Colorado. This is the average day today near the Grand Canyon. And that difference is the water that we have taken out of the system. That's water withdrawals, net water consumption. What we see here, of course, is most of this is for irrigation. A fair amount of this is also for cities like Phoenix and Scottsdale, and there are a lot of golf courses there if you've ever been there. So it's a pretty water-intensive place. But what's really, truly astonishing is if you continue to follow the Colorado River down towards the ocean, it dries up completely in its riverbanks and disappears into the sand. We have already consumed entirely the Colorado River. And we're doing it for what? Bad iceberg lettuce in the desert and some golf courses. That's crazy. But it's not the only example. This is not just the US, it's all over the world. Many of you are familiar with this example, of course. This is kind of the granddaddy of water mismanagement on Earth today, is the Aral Sea. Now again, probably half of you already know this story, so I apologize if you're hearing it again. But the Aral Sea is in Central Asia, and what are today the countries of Kazakhstan and Uzbekistan, you see in the map behind me. This is an arid region. It doesn't rain much here. The only reason that there is a sea here is because these two rivers, the one right up there and another one right over here, are feeding the Aral Sea depression with water because way over there, way to the east, over towards China, there are mountains where snow falls, the snow accumulates, melts in the spring, and that meltwater falls into this big bowl of sand and forms the Aral Sea. But as a lot of you know, the Soviets, actually when this was still part of the Soviet Union, diverted these two rivers and used some of that water to grow cotton in the Kazakh desert. And they basically tore up the water supply of the Aral Sea, getting some basically pretty poor cotton production out of the Kazakh deserts. Well, you can imagine what would happen if you turned off the water supply to the Aral Sea. It goes from this in 1973 to this about 3 years ago. This is an extraordinary change. To an American, I tell them, like, well, imagine this is Lake Superior, and that's your cabin right there. And it just moved 300 kilometers away. And, well, I have to tell them in miles because we don't speak metric. Yeah, I love that. The United States, Burma, and Liberia are now the 3 countries left on Earth that still use the English system of units. That's fantastic. I gotta love that. But anyway, so this is an extraordinary change here. And again, for what? One of my graduate students actually printed up a T-shirt with those 2 photos on it. It said, "We drained the Aral Sea, and all I got was a lousy cotton T-shirt." And, well, okay, some of you got that joke, but it's, that's a bad trade-off. Well, it turns out whether it's the Aral Sea, the Colorado River, the Agawa Aquifer, or Lake Chad in the Sahel, or a lot of the rivers in China today, we see that we are consuming an extraordinary amount of freshwater resources, estimated to be about 2,800 cubic kilometers of water a year. That's extraordinary. It's estimated to be, by some people, about half of what the renewable available freshwater resource even is on this planet. That is, the water that's flowing across the Earth's continents into the oceans every year. And of that water that we do use, between 70 or 90% of that, depending how you do the bookkeeping, if it's net or gross water use, is used again for one thing: agriculture, irrigating crops. We'll get back to this in a minute and how we can make this a lot better. But an extraordinary water footprint is tied up in our food. So we've run out of kind of an easy planet worth of land. We see problems with water all over the planet. And of course, we see the problems of climate change. Now, I like to think of climate change as that we're kind of running out of an atmosphere. We're not running out of air to breathe. The stuff we use from the air is just fine. But we've been using the atmosphere as an extremely convenient dump for, well, about 150 years now. We've been pumping things like methane and nitrous oxide and especially carbon dioxide into the atmosphere and thinking it's just going away. But of course, it's never away. It's just building up in that shell of air that surrounds our planet. And just last week, we crossed the 400 parts per million level at Mauna Loa Observatory for the first time in, well, probably several million years. So we have an extraordinary change to our atmosphere that's happening. And we usually think of this as primarily an energy problem. We're burning too much oil and coal and natural gas and so on. Well, that's part of the story. In fact, about 60% of the greenhouse gases that come into the atmosphere are from energy, from using fossil fuels. But it turns out about 30% of global greenhouse gas emissions come from agriculture. In fact, of any economic sector, agriculture is by far the biggest emitter of greenhouse gases of anything we do on the planet. The second largest would be all the world's transportation. Every car, every lorry, every truck, airplane, bus, train put together is only 15% of greenhouse gas emissions. Agriculture is 30%. Now, most of that is coming from deforestation. Second would be methane, coming from cattle and rice fields, and third would be nitrous oxide from overuse of nitrogen fertilizers. Way after those three would be the things you might see a little bit more in Europe and the United States: energy use on the farm, some other kinds of uses for making fertilizers and chemicals and so on. But the big three are deforestation, methane, and N2O. That's really what we have to tackle. So the point here is that we're hitting very big planetary limits, very fundamental limits that we can't negotiate. We can't just invent our way out of. They're dealing with land and water and even the nature of our climate and the atmosphere itself. And a lot of those limits are being hit today because of the way we grow food. Agriculture is in the driver's seat in terms of what's happening to the global environment. We often look at energy, but I think overall, agriculture has so far been responsible for more of the changes we're seeing on the environment than anything since the last ice age. So we really have to address that concern too. So this is really a big issue, but it's much more than an environmental problem. I get really tired of environmentalists kind of capturing the agenda and only framing things that way, saying it's the environmental problem. Like, well, great, 3% of the world will follow you. What about the other 97% who care about other things like their security, their economic prosperity, their health, their well-being, how their children are doing, those kinds of things? So if we think about this a little bit bigger, it's not just an environmental problem, it's really, I think, a civilization problem. Like, do you get to have one? If we can't feed ourselves and feed a growing world and make it also sustainable in the long run to do that, then we've got a big problem. It means our own civilization itself is probably not sustainable. So we have some hard work to do. And it requires we ask some extremely hard questions. Questions that are very uncomfortable, very inconvenient questions to try to even pose, let alone answer. But one of those, of course, is how we feed a rapidly growing world, something I know a lot of you were talking about today, the central crux of what agriculture needs to do in the coming decades. But the part I'd like to address as well is to do that while we simultaneously sustain the planetary resources we absolutely depend on for everything. So how do we do both of those things? That's really the big question. Well, I like to break it down. Let's do it into kind of three parts. So part one, of course, is today. Can we meet the current needs for food security today? There are 7.2 billion people on Earth. There are estimated to be about 850 million people, call it a billion in round numbers, about a billion people who are probably food insecure. Is that because we're not growing enough food? Nope. It's because about a billion people cannot afford the food on Earth today. It's a question of markets, poverty, infrastructure, and governance. It is a failure of institutions and governance, not a failure of agriculture. That's certainly true. There's plenty of food to feed the world we have right now. That's true. And ironically, we have another billion people in the world, mostly in my country, but spreading into some of yours too, who are probably overweight and obese. So, that's pretty weird. We have 2 out of 7 people in the world who are not being served particularly well by our current systems. But that's not a failure of agriculture. It's a failure of diets and affluence and a failure of poverty and institutions. So we have to address that problem, to be sure. But as we look into the future, and I'm sure you talked about this today too, as we think about the future and what the demands on agricultural products will be, we are looking at some major driving forces that are increasing the demand for agricultural commodities. Of course, we all talk about the population growth because that's easy to imagine. There are 2 billion more people coming for dinner. Okay, I hope we have a lot of extra chairs. Okay, because you're going to need every extra chair we've got. 2 billion more people coming from dinner. But most of the population growth in the world is happening in relatively poor countries. But let's say their average income, 2 billion more out of 7, that turns out to be about 28% more mouths than we have on the planet today. So if this is the only thing happening, we'd have to grow 28% more food to make up for the 28% more people we'd have by mid-century. I think we could do that. But it turns out that's not even the problem. This is the easy part. That's not a problem at all. The hard part, and the one nobody wants to talk about, is there are 4 billion people on Earth right now who are suddenly getting wealthier. China alone is adding 500 million people to the middle class in the next 15 years. That's extraordinary. Then you add India, Russia, Brazil, Vietnam, Thailand, Indonesia, etc. We have a burgeoning global middle class. First time in human history that's ever been true. We've never had a global middle class before. We had very small numbers of very rich people and a very large number of extremely poor people. But now there's a global middle for the first time. Actually, that's pretty cool. That's a great thing in many ways, but it's a huge challenge because every time in human history, including right now, that people get wealthier, they eat richer diets, usually richer in dairy products, in meat, in sugars and fats and oils and all these kinds of things. So that's really the bigger side of what we are projecting future demands to be. So there have now been about 6 different studies, I believe, that have tried to look at the population side of the equation and the wealth and changing diet side of the equation. And when you put all those together, every single one of them arrives at a number something like this, that if, and this is a big if population grows the way we expect, and if the economy grows the way we expect it to, and middle class numbers quadruple basically, and they go the way that diets have gone before, then, if all those things are true, we're on a road right now that would need to double approximately the world's food output by 2050. Well, it took us 10,000 years to do what we do right now, and we have to double it in 37 years. That's very hard. And I'll tell you later, I don't think we're anywhere near capable of doing that with the strategies we have right now. And we'll have to change those strategies dramatically. So the third problem is, so we got to make the world food secure, double it in about 35 to 40 years, and then make it truly sustainable. And then if that weren't hard enough, we have to do it all simultaneously on the first try. We don't get to do this more than once. We get one shot at it, and if we fail, we're screwed. Right? So, I'm a professor at a university. My students hate this because this is like the final exam from hell. Okay, like you fail this test, we die. They really don't. Nobody takes my classes anymore. They're too depressing. So this is a challenge. So how are we doing right now? If we're going to look to the future, we better ask, what are we doing at this moment? Well, let's take a few numbers out here. It turns out over the last 20 years or so, the amount of farmland, just the acreage, the amount of land put into production, has increased a little tiny bit, about 2 to 3% over the last 20 years. There has been some expansion of agriculture in the rainforest regions of Brazil and Indonesia in particular. That's probably the last place you want to expand. But then we've been losing agricultural land in places, well, especially China and India, a little bit in Europe, and a little bit in the United States, to urbanization, suburban sprawl, and land degradation. So on net, we've lost some in some places, we've gained it in others. There isn't really more farmland than there was 20 years ago. It's about the same. So what have we been depending on? We've been depending on the Green Revolution. We've been depending on yields will always go up and up and up. And if you look over the last few decades, that's largely been true. So these maps show, for example, the darker the red color here shows the increasing yield of rice. So the darker the red, the faster the yield increases. Over here for corn, showing, here in the Midwest of the United States and Brazil and Argentina and Western Europe, boy, those yields were going up like crazy if we look at a long time frame of maybe 30 years or so. But what's really concerning, and most people aren't even aware of this, is the Green Revolution is starting to end, at least as we know it now. If you look carefully at the data for yields around the world, and we just published a paper on this in Nature in December that you can look at if you'd like, we're beginning to see some incredible stagnation of yields, at least in a few of our most important crops. This is a map showing maize, corn around the world. Corn's doing well. Corn is fine. Everywhere in the green, basically, are places where the yields are still going up. In the bright green, they're going up really fast. But in the brown areas, throughout some parts of Central Africa and a little bit over here and a little bit in the Mediterranean, corn yields have stagnated for 10 years. There's been no statistical improvement in yields whatsoever. And in Zimbabwe, not to anybody's surprise, we've seen a collapse of corn yields over the last decade. And we know why that is. But corn doesn't concern me that much. What really concerns me are the two crops that actually feed the world, rice and wheat. Rice and wheat provide half of the calories of the human diet every day. Those two crops. If you want to make the world food secure, you have to think about wheat and rice. Nothing else comes nearly as close to feeding the world as those two crops alone do, at least on a calorie basis. So rice, we're seeing a very disturbing trend. About 35% of the world's rice-growing lands have seen complete yield stagnation. No improvement for over 10 years. All of those places in the tan color here. Throughout Asia, Australia, and so on, and throughout Africa, it's just incredible. We go to wheat, it's 40% of the world's wheat lands are no longer improving in yields. On every single continent, Europe, Asia, Australia, Argentina, over here, Western North America. Those two crops are the pillars of food security, but they've not received the same attention as soybeans and maize and other more high-value commodities, and they're lagging behind. We're seeing the end of the Green Revolution of Norman Borlaug and the things that helped feed the world for decades. What's happening now? So I'm very, very concerned about this. I think we have to really look this in the eye and ask what's going on here. What we're also seeing is if we truly wanted to double the amount of food by 2050, yields increase basically linearly. They don't increase compounding interest or geometrically. They're a linear increase. All of history shows that. What we find is if you really wanted to double the availability of those four crops, for example, you'd have to increase at a rate of about 2.4% per year between now and 2050 to get to about a doubling. But the solid line is the rate they're actually increasing. So the dashed line is what they need to be, the solid line is what they actually are. And if we project them forward, we're finding we are falling way behind by a factor of 2 what we need to do to actually double the availability of calories in the world by 2050. We are not on track to do that. But the problem is we've only been using one paradigm. Some of you have been in the United States the last few years. You might have heard crazy people in the US yell, "Drill, baby, drill." Have you ever heard that expression? Yeah, it's like just this, the conservatives in the US will just drill anywhere to get oil and gas. I don't care what the consequences are. And they pretend that that's an energy strategy. Just drill every hole you can and find something in it to burn. I think we've been doing that same kind of thing a little bit too much in agriculture too. Maybe we've been yelling to ourselves, "Grow, baby, grow." That we've been thinking, how do we get the plants to grow more? Let's just grow more stuff, grow, grow, grow. That strategy worked for a while during the Green Revolution, but unfortunately, it seems to be petering out. It's only half of the possible solutions we have. It's ignoring the other half that we need to consider as well. And right now, I'd argue it's not a strategy that will get us to food security by itself. It will help, but not by solve all of our problems. It's currently not keeping pace with demand. The numbers do not line up at all. And it's certainly not environmentally sustainable the way we're doing it today. So how are we going to do this? Well, I'm arguing that we need to find a lot of other solutions. And my colleagues and I have spent a lot of time building international teams that are saying, how can we develop criteria for food security and the environment? Saying if we can't do food security and environmental sustainability, we will have failed. We have to do both of these things. So we've developed metrics for looking at, what are the things about food security we care about? The total amount of production, how much of that is nutritious, kind of real food, how it's distributed and made accessible, and how resilient it is to economic shocks, trade barriers, diseases, climate impacts, et cetera. Also down here, though, are issues around the environment, whether it's climate change and greenhouse gases, biodiversity losses, water pollution, water withdrawals, and so on. That circle represents where we need to be by the year 2050. So that's the target. How are we doing? Well, right now, as I've shown you so far, we're not meeting the goals of food security, and certainly not in the future. We are maybe halfway to where we might need to be in those regards. A lot of work needs to be done in the next 3 to 4 decades. And on the environment, we're clearly doing so much more environmental harm than is possibly sustainable in the long run that it's completely out of balance. We're not getting enough food security, and we're causing too much environmental harm to maintain for the long term. So what do we have to do? We have to figure out strategies that enable more food security and simultaneously, at the exact same time, reducing the environmental impacts of the way we farm. That's the more balanced future that's truly sustainable and what we need. So what we have to do is test every single strategy we have in agricultural science and policy and economics, et cetera, and ask, what do they do across those sectors? And if they don't achieve a good balanced solution, then we throw it out and we start over. When we did that and we tried out dozens and dozens of different strategies, we boiled it down to about 5 kind of very large framings for strategies that could maybe be a place to have a conversation. So I'll just tell you where those are. Those 5 different strategies were basically aimed at doing this. How do we double the amount of food in the world by 2050 and cut in half or more global environmental impacts? Things like climate change, biodiversity loss, water withdrawals, etc. Well, it turns out you can do this, but you have to think about 5 major domains. First of all, I think you have to think very hard about deforestation. Deforestation on the environmental side is by far the single most destructive thing we do on Earth. Nothing else even comes close. In terms of greenhouse gas emissions, the losses of biodiversity, the disruptions of water supplies, watersheds, water quality, unbelievable. Nothing else even comes close to this. And what's ironic is, even though we're causing all of this environmental damage, we're not really, most of the time, feeding the world's poor by clearing rainforest. Large areas of forest cleared in Brazil and Indonesia were used for what? Soybeans and beef for global middle-class citizens, or timber and palm oil for middle-class people. Who's feeding the poor here? Nobody. We weren't feeding the poor by doing that. What we're doing is we're causing huge environmental harm and creating some things that benefited the middle class. And maybe a few people got rich along the way. I'm not sure that's a trade-off our civilization wants to make. I think that's a bad trade-off. We could do better. So if we move away from deforestation and say we should not enter into remaining natural areas of forest from their value of biodiversity and natural capital and carbon and so on, we just don't want to do that. We'll have to figure out ways to grow more food on the land we already have. We don't want to clear more land. Let's stay with the land footprint we have today. So we can do that by improving yields. The problem is, as I've shown you, our yield improvements seem to be petering out for a lot of our key fundamental crops like wheat, rice, and others. But, and a lot of you know this better than I, there are plenty of places in the world, if you look at what's called a yield gap, areas that are underperforming relative to their soil conditions and their climate, places that are not doing all that well for the yields that could be possible on the lands they have. So for example, for maize, we see many regions in South Africa, West Africa, even parts of Mexico, where yields are maybe 20 to 30% of their current genetic potentials. Wow, that's possible to double, triple, quadruple the yields here. That's fantastic. Even in Europe, Eastern Europe, of course, and on the other side of what used to be the Eastern Bloc, we see a lot of lands, some of the most fertile lands in the world. This was the great breadbasket of Eurasia was here, but it moved between Frankfurt and Brussels during the 20th century. Now there's all that land on the other side that is still only getting maybe 20 to 30% of their potential yields for things like barley, wheat, maize, and so on. Mainly due to institutional issues and lack of good agronomic practices still, but huge areas of incredibly productive land. So there are lots of opportunities if we can solve these problems to figure out how to grow more on the land we already have. In the United States, we tend to want to do this through fancy genetic technologies. We all talk about GMOs and how they're going to feed the world. I'm not anti-GMO, but I'm kind of skeptical that they're a solution in many parts of the world, when most of the time yields are not limited by genetics. They're still limited by agronomics. Are they getting enough nutrients, for example, in the red areas? That's what's limiting maize production in Eastern Europe and most of Africa and Latin America. It isn't GMOs. That wouldn't help at all. You need a little manure or a little bag of NPK. That's what would help. Or in the blue areas, maybe they're more water limited. So you need the appropriate kind of intervention in the appropriate geographies. It's only Western Europe and the United States and maybe some parts of Southeast Asia that are really limited by current genetics if you want to grow more maize. So we see opportunities, but we have to use the right kind of opportunities at the right place and focus more at the base of the pyramid than the top. Right now, it's much easier to lift the floor of the yield distributions than raise the ceiling. We've put all our effort towards the ceiling naturally, because that's where a lot of us have invested a huge amount of money and time and attention. But there's a lot of land out there at the floor, and that can be lifted too. So those are two things we have to think about. We also have to think about radical improvements in the efficiency of how we do agriculture. Again, most of the world's agricultural output is still using kind of a more industrial methods of agriculture, kind of high input, high output, green revolution technologies. We talk about organic and other things, but that's still a small fraction of the world's agricultural systems. A lot we could learn from there, but for the most part, we're still using kind of a high input, high output system. But we could do it so much better. So one of the things we've been looking at is how efficient are we at using different resources in agriculture, for example, water. Now, I love to show this picture to students every year in my classes and say, can you invent a machine that wastes water better than that? And for 10 years, no one has been able to do it. I mean, like if you wanted to make an evaporation machine, that's what that's not an irrigation machine, that's an evaporation machine. Even an open swimming pool wouldn't evaporate that much water. It's absolutely brilliant if your idea is to waste water. This is magnificent engineering. But then I'm like, oh, wait a minute, you're trying to grow food? Oh my God, that's incredibly dumb. Now, there are reasons we do this. This is a typical US center pivot system because water is subsidized in the United States. Taxpayers pay farmers to get free water, and very large amounts of it. And this is convenient, efficient, in terms of time and the farmer's income, but it's not good from a water side of things. So what we like to look at is how much water are we using around the world? This map shows the kind of irrigation belts across Asia, Central Asia, Europe, the United States, and so on. Those big blue areas are places where we heavily irrigate the land. The darker the blue, the more water we spray on the ground to use to grow crops. So that's interesting if you care about water, but what if you care about the link of water and food together? What's really interesting is that on average around the world, it takes about 1/3 of a liter of water to make 1 food calorie. So if you ate 3,000 calories a day and you were a vegetarian, then you would need approximately 1,000 liters of water to grow your food every day. If you ate any meat or any dairy products, add 2 zeros to that number. Okay? So we all eat far, far more water than we ever drink. Water is really food, it's not water. But that 1/3 of a liter number varies by orders of magnitude. You can't see it on this map here, but if you zoomed into Israel, for example, they're about 5 to 10 times more efficient than the global average. The Israelis have perfected things like drip irrigation, have done incredibly good agronomic practices with irrigation, and have really raised the bar on the world in terms of how we take water and use it to grow food. They had to. It's a national security issue there, makes complete sense. You go to the other extreme, though, let's say over here in northwestern India and Rajasthan or Pakistan or Iraq or Sudan, you see it's about 5 to 10 times worse than the global average in terms of this quantity. How many liters of water does it take to make 1 calorie of food? So between the Israelis, let's say, and northwestern India and Pakistan, there's about a factor of 50 to 100 difference in the efficiency of turning water into food in similar climates. So if you had 2 firms, one here and one here, and yours uses 100 times more water than that one, what would you do? You'd try to copy that guy and figure out how they're using that technology. So while there's huge opportunities here, they just haven't been realized because water isn't priced adequately. We have a lot of issues here about pricing and governance of water. But again, the technology exists to have radical improvements in efficiency, 10-fold to 100-fold improvements in water use efficiency. And these are incredible low-hanging fruit opportunities. There's nowhere to go but better in this situation, and that's fantastic. Similarly with fertilizer use. If we consider the world's nitrogen use, for example, this is kind of the darker the green areas. We show more nitrogen fertilizer applied on the landscape. China, then India, then the United States, and then Europe. Those are the 4 big fertilizer hotspots on the planet. But we don't use fertilizer especially well. Many of you know the story of Goldilocks, right? Everybody know that story? Anybody? Oh God, maybe I don't know. Okay. Everybody know that one? Okay. Well, so Goldilocks, there was, this bed is too soft, this bed is too right. Okay, and there's one that's just right. Everybody know that story? Okay, I don't know. Okay, I'm sorry. That's maybe just a weird North American story. Sorry about that. But the problem is, we use fertilizers, often we use either way too much or not enough. We very rarely use it just right. So these 2 examples, for example, in China and Shandong, China, we see places that are getting incredibly high yields of maize, maybe 9 or 10 tons per hectare for that region is pretty good. But they're using like 220, 230 kilograms per hectare of nitrogen. That's insanely high rates of nitrogen use. Unbelievable. But over here in Ethiopia, they're using almost none, and they're seeing very, very low yields, only 1 ton per hectare. So we have either too much or too little. And most of the world is that kind of schism. It's either too much or too little. Very little is actually done at the optimal areas. Like, hey, if you increase the fertilizers available here, you could quadruple the yields in Ethiopia. Or you could reduce fertilizer use by 50% in China, in this place anyway, and have absolutely no impact on yields whatsoever. So if you did this globally, this is just a thought experiment, this is probably never ever happen, but we went and looked around the world and said, where could you dramatically reduce fertilizer use with no impact on yield? And where could you improve yields by increasing fertilizer use? All of the red and orange areas are like the US especially, China, India, a little bit of Europe. These are places where fertilizer use could be still brought down considerably. Europe has done the best of those 4 places, of course. China and India are probably the most polluting with fertilizers. The United States is pretty close. Europe has come the furthest in fixing this problem. But other parts of the world, especially Africa and the eastern part of Europe and other places, more nutrients are clearly needed to make those crops grow better. So we could be so much more effective in the way we use agricultural inputs like fertilizers as well. So that's good news. Huge opportunities with water and fertilizers and other agricultural inputs. That's good. So what we've done is we've figured out that we can still grow more food with less land, less water, and less inputs. There are ways to do that if we think about the systems through efficiency and base of the pyramid solutions rather than top of the pyramid solutions. So that's good opportunities. But this is still all on the supply side of the street. Now if we look in the other side of the street, we can look at how demand is manifest throughout the world. What do we use the stuff we grow for anyway? And that gets us into very thorny questions around diets, biofuels, and food waste. But let's start with diets. This is the most controversial of all. Diets are important because we live in 2 radically different worlds. We live in the green world, some of us, let's say China, India, Africa, the Mediterranean countries, California, through much of Latin America. Those are the places in the world where their crops are being used to feed people directly. What this quantity shows is how much of the crops that are being grown are fed directly to human diets. So things like rice, wheat, fruits and vegetables, ground nuts, pulses, roots and tubers, things like this. The red parts of the world, which include a fair amount of Western Europe, definitely the United States, especially near where I live, those places are not feeding people primarily, they're feeding livestock, and increasingly in the United States and a little bit in Europe, feeding biofuel production. In fact, in the United States, the dominant use for corn right now is making ethanol. Second is animal feed. So if you look into that, now that's good because we like ethanol apparently, we like otherwise we wouldn't make them, I guess. And there are issues, people like to eat dairy products and meat, so that's very understandable. But the red world and the green world have a very different efficiency of feeding their populations and feeding the world. Very, very different. So if we looked into this a little bit, we have to look into the efficiency of converting grains into animal products, for example. Now, many of you are much more an expert on this than I am, and these numbers vary greatly around the world. But these are numbers for the United States, according to the US Department of Agriculture. These aren't my numbers, they're the official US government numbers for the conversion of grain. If you had 100 calories of corn and soybean, let's say, and you turned it into milk or eggs or chicken or pork or beef, these are the efficiencies of calories you'd get out. Or if you had 100 grams of protein in corn and soybeans, how many grams of protein would you get out? That's pretty good, 40% to 40%. But over here, towards the end, we're finding beef production is pretty inefficient in some ways, if you look at the conversion on a calorie basis or on a protein basis. Now, the beef industry likes to do it on a weight basis, where they include the entire animal weight, live weight. So it's including bones and hide and organs and things that are not consumed by people directly, but are still economically valuable. So you have to consider, is it a weight basis or a calorie basis? They're very different numbers. But you look at are we feeding the world this way? This is not maybe entirely efficient. For example, in the United States, we often look at yields as tons per hectare or bushels per acre in the American units. But what if you looked at it in terms of how many people you keep alive per hectare? How many people are alive today thanks to that hectare of land? How many people do you actually feed a diet today? So this is a map of what the United States could be doing. We could, in the great corn belt and soybean belt of the United States, this is one of the most productive regions of agriculture on the planet. I happen to live right about there, right on the northern edge of that. It could, if we ate that corn and soybeans, feed about 16 people per hectare, which, on an annual basis, about a 2,700 calorie diet. So assuming no food waste, and everybody was a vegetarian eating corn and soybeans, if we could eat that stuff. Well, okay, but we don't. What do we actually do? Well, when you include biofuels, you include meat and dairy products, we go from 16 people to about 5. We come in just behind Bangladesh in feeding people on the lands of the central United States. It's highly productive, but we use it rather inefficiently. So there's a 2/3 of that productivity is sort of lost in the system while creating high-value products that people do demand. And I'm not suggesting everyone become a vegetarian and give up biofuels, but there's a very large opportunity space here to think about. Are diets and biofuels something we can negotiate? Is it something we can talk about? Or is it verboten? Is it like off the table? It's at least it's worth putting the numbers out there. That if we're talking about doubling the productivity of that system, I know how to do it right now. Less beef and less ethanol, you're done. You don't have to do anything right, you could triple it. Right there, you're done. You don't have to do a single thing else. But we don't talk about that. Instead, we talk only about growing more corn. So I think we have to not just look at one side of the street. It's worth looking over there to see, are there opportunities? And there are a lot. Moving globally, this is now not just the United States, this is the entire world. We see how maize, actually, if we ate it all, produces more calories innately of corn around the world. But the green bar is actually what's delivered to the human diet. Most of that is in the form of dairy products, then meat, then high fructose corn syrup, believe it or not, and then corn itself as cornmeal, grits, hominy, things like this, corn flour, etc. Wheat and rice, we convert very efficiently. Then you get down here to other crops and so on. So we see those red bars. Those red bars represent losses that are because we choose to make biofuels and animal products, which again, I'm not criticizing that, but it's just to be aware that those opportunities for maybe being fluid about that are there. So if we look at this whole number, we have about 60% of the world's crop production is fed to people as food, but there's about 40% that's lost due to some inefficiencies of conversion, either to biofuels or to meat and dairy products. We should be thinking about that. So let's put that aside, and that's going to be controversial, and we'll all have different opinions about that. But I'm sure nobody would argue with this one. There's nobody here from the lobby that promotes food waste, right? There isn't one. That's good. Nobody here is from the pro-food waste group, right? Anybody? Well, maybe there is, and I'm really offending somebody right now, but I've never met a, let's waste more food organization. So let's find out what we can do there, because there's another, in addition to the allocation of how we use our food and our crops, there's another 30 to 40% conservatively of the world's food is wasted. In rich countries, in Europe, the United States, other places, we tend to lose it at the consumer and retail end of the spectrum. So we there lose food. We lose it in our cafeterias, our restaurants, our home refrigerators and kitchens, and so on. But in poor countries, they typically lose another 30 to 40% as well, but it's much closer to the farmer. It's usually between the farm and the marketplace. So not only do they lose the food potential, but also lose critical incomes, and it's a double tragedy. So that's an area where, again, huge opportunities are possible here, yet the relative investment in dealing with food waste versus growing more crops we may not even need is crazy. We have, I'd like to see even a penny for every euro we spend on promoting yield improvements. Could we spend 1/100th of that on tackling food waste? Because we don't even do that. That is a completely unbalanced portfolio. It's a failure of markets. It's a misuse of capital. There's more opportunity here than in GMOs or in new agronomics or precision agriculture, and nobody is investing in it. I think that's really a shame, and it represents a huge opportunity. So what are the business models that can make that work? We should talk about that. Well, to kind of wrap up a little bit here, there's good news, okay? While there's some kind of scary stuff here and things that maybe help things we have to think about, the good news is there are totally a lot of opportunities here to feed the world and sustain the planet. The good news is it's possible. It is not physically or biologically inconsistent to do this. We can actually do this. Solutions do exist. We just don't have a lot of them on the table right now, because it requires a big shift in some of our thinking from just being grow, grow, grow to, well, grow more with less and doing other things like this. The two mantras should be not grow more, it should be produce more with less. How do we deliver more with less land, less water, less chemicals? That must be the new mantra of agriculture. And how do we use what we already grow more effectively, more efficiently for more human well-being? Those are the two opportunity spaces for agriculture in the next few decades, I think, to solve those joint problems of food security and the environment. There are also some really, and this sounds like big, kind of ubiquitous kinds of problems, but there are places where we can actually focus some strategic leverage points that could be very effective. And I just want to show you a few of those, and then we'll wrap up and hopefully have some time for questions. One of the things that's really important is to know where to focus, because we could spend our time looking at under every rock and every place, like how do we solve that problem, this problem, that problem. In a lot of Europe and the United States, there's a lot of debates around GMOs and organic and local food and all this kind of stuff. Okay, great, that's fine, but if you really want to change the world, look at these places. For example, deforestation, I told you already, is one of the single biggest issues we have. About half of the world's deforestation in the last 10 years happened in only two countries, Brazil and Indonesia. And in those two countries, we find that basically are only four commodities that mattered. Beef and soybean over here, timber and palm oil over there. Well, what we've seen in Brazil in the last 4 years has been remarkable. There's been an 80% drop in deforestation rates in the Brazilian Amazon in the last 4 years. That's incredible, mainly to do with soybean certification, Brazil enforcing its forest code better, more civil society, more public-private partnerships. That's been incredible. That has not yet been replicated at all in Indonesia, but now we know where to focus. Indonesia is the place to focus if you want to think about climate change and biodiversity and food production. You have to look there. That's really huge. Same thing with water. If you care about water in agriculture, I mentioned earlier, there are some places in the world that are disproportionately important. For example, India. India alone consumes 50% of all of the irrigation water on Earth. Every other country in the world combined is only rivaling India. So if you care about water and agriculture, go to India first, then to China, then the United States. Those are the top three. Those three countries together represent about 3/4 of all the water consumption on Earth for agriculture. And of that, about 80% of that is in three crops: rice, of course, wheat and maize. Add a few more, you get up to 93%. So there are these strategic leverage points, kind of 80-20 rules, where 80% of the problem almost is in maybe 20% of the entire system. There are places to focus. Same thing with food production. We found that there are about 6 regions in the world with very small investments in just inputs of nutrients, maybe a little bit of water, very, very small investments, could add enough calories to feed almost 500 million people with extremely small investments, much less than we're making already in different kinds of agricultural technologies. but we have to put them in different places. So there are geographic foci to focus on. Of course, there are supply chain focus areas as well. The rise of the Chinese middle class represents a singular opportunity to think about international trade and food security. This right now just shows this incredible rearrangement of global trade routes. This is animal feed trade going into China. If you made, this is for 2010. If you made a map of this for 5 years previous to that, it wouldn't even be visible. So we've seen this explosion of reorienting global trade routes towards China to meet the largest accumulation of wealth in human history. So if you want to think about things, what right now would be an important place to focus is what will be the aspirations of Chinese middle-class people in terms of diets and biofuels. What they choose to do will steer a lot of the world in the future, and we have about 5 to 10 years to maybe do something about that. And then it's probably burned in and too late to change it. So that's another huge opportunity that we have to seize right now, and that's something that would be worth talking about. So anyway, to wrap up, I guess, the good news here is there are a lot of reasons to be optimistic. There are lots of tools at our disposal. We know what's possible. We have more than enough tools to do this. What requires some changes? Yes, some attitude changes, changes in institutions, business, investments, governance, and so on. Yes, of course. We don't have to change the laws of physics. We have to do something a little bit harder. We have to change our minds. And that sounds harder sometimes, which is ironic, because that's the easiest thing we should be able to do, but it seems very hard. But that's what we have to do. And finally, going back to where I started from, we have to get very good at this very quickly, because we are living in this inflection point in history, whether we like it or not. None of us were asked to be here. When I talk to my students, I tell them, you didn't ask to be born right now, but guess what? Too damn bad. You were. Here you are. You're stuck with it. And you've inherited the most important time in human history to be alive. What we do now, during the next decade or two, will determine the future of things like our climate system, or the fate of biodiversity, or which peoples get an adequate diet and which don't, and how we'll preserve the world's water and resources and land and soil. The next 20 years will be crucial, not only for the next 100 years, but for the next several thousand years, because of how we're inflecting the whole system right now. So we have to make a choice. Fortunately, we still get to make a choice, but it's a very simple choice. And this is how I tell students about this today, kind of younger people. I tell them, you have to make a choice between the people we usually are, short-sighted, not really interested in changing the way we do things, kind of selfish, and don't really want to think about the big problems, versus the people we could be. We've had a lot of people here in previous generations have stood up and made the world a lot better. How can we do that? And we have to make a choice between the world that is, where 1 billion people are food insecure and we don't know how we're going to feed the rest of the future, versus the world we know we want, the world that should be. And Robert Anton Wilson once said, "The future is up for grabs. It belongs to any and all who will consciously create the future they want by design." So with that, I'll say thank you very much for your time, and I hope we have a little bit of time for questions, and appreciate the time you have today and look forward to some conversation. So thank you very, very much.